Hello everyone, welcome back to another video. Today we're going to explore an efficient Java solution to the reverse an integer problem while handling overflow and underflow conditions. This approach cleverly uses simple arithmetic operations to tackle the problem. This is number 7 on LeetCode and it's just called reverse integer. Now before we get into the code, if you guys want to see more videos like this, drop a like down below. It helps us out tremendously with the YouTube algorithm. With that out of the way, let's hop right into it. Alright, so in this Java solution, we're given a class named solution that contains a method called reverse, which reverses the input integer x while carefully handling overflow and underflow conditions. We begin by declaring an integer variable rev and initializing it to 0. The variable will store the reversed integer. The heart of this solution is in the while loop, which iterates as long as the input integer x is not 0. Inside the loop, we use the modulo operator, or the percent, to obtain the last digit of the input integer x, which we store in the variable pop. Next, we update x by dividing it by 10 using the compound assignment operator divided by and equals. This operation effectively removes the last digit from x. Now here is the crucial part of the solution where we handle the overflow and underflow scenarios. The first conditional check is to prevent an overflow for positive integers. We check if rev is greater than integer.max value divided by 10, or the maximum value of a 32-bit signed integer divided by 10, or if rev is equal to integer.max value divided by 10, and the last digit pop is greater than 7. If either condition is true, we immediately return 0. Similarly, the second conditional check handles underflow for negative integers. We verify if rev is less than integer.min value divided by 10, the minimum value of the 32-bit signed integer divided by 10, or if rev is equal to integer.min value divided by 10, and the last digit pop is less than -8. If either condition is met, we return 0. If none of the conditions above are met, we safely update rev by multiplying it by 10 and adding the last digit pop to it. This operation effectively reverses the integer. After the loop, we've successfully reversed the integer while handling overflow and underflow scenarios. And finally, we return the reversed integer rev, which is our answer. Now let's go ahead and run it. Alright, so that's going to be it for this video. If you guys enjoyed or found this video helpful, drop a like down below, drop a comment if you have any questions, subscribe for more, and we'll catch you in the next one.